Hola, welcome to our presentation on curating Twitter datasets to learn troll behavior to distinguish them from real users. This is a joint work between myself, Albert, and my supervisor, Professor Reihaneh Rabbany from Mila and McGill University. In the current times, social media provides a crucial scenario where freedom of speech puts democracy at stake. Within the rapid flow of information, it is not surprising that malicious attackers often target Twitter users to take political advantages, as reported in recent literature. This motivates us to study how state-backed accounts, namely trolls, behave differently from real users. We take a three-step approach in which we curate a set of troll datasets along with close real users, and then we learn their behaviors by performing a link prediction test. Finally, we use the acquired knowledge to classify them. A few years ago, Twitter's transparency operations started releasing a huge set of accounts, each of which has been manually identified to perform state-backed operations. The Twitter Information Operations Database has been consistently renewed since their initial 2018 release, or of 4,383 accounts. Following the official reports, we refer to this set of accounts as the Twitter Election Integrity Dataset, which includes over 800,000 hashtags, 2 million users, and all of which come from around 22,000 suspended fake accounts. In particular, we use three subsets of these accounts, which come from Russia, from China, and which are identified to originate from the Internet Research Agency, or IRA. The dataset is inherently a dynamic network of user interactions where everyone is interacting indeed with other users within the graph while engaging in common topics. Here, for instance, we visualize a year of interactions within the Chinese dataset. Orange activity depicts troll interactions, while the blue ones are part of a sample of real users we study afterwards. Also, green nodes represent hashtags, while pink ones stand for users. Now, to be more specific, we construct a mention graph from hashtags and users. We collect a set of mentioned users by the reported trolls, that is their one-hop neighborhood, which we crawl the respective mentioned hashtag activities. We extract all available tweets from a defined time frame to build a heterogeneous graph that follows the pattern depicted on the figure. For link prediction, we propose a deep learning pipeline which we divide in three steps. First, we sample a set of tweets from a predefined interval. Also, we sample negative links that will help us define our link prediction task in later stages. Next, we build node attributes per each user. We use the meta path-to-back algorithm, which builds on top of the popular node-to-back, but predefines the types of paths the algorithm could only traverse. Finally, we choose the SEAL framework, that is a graph neural network architecture with node labeling, to perform our experiments on link prediction. Our unified pipeline is summarized on this algorithm, where basically our learned link embeddings provide crucial information that is unified by a pooling operation to perform a final classification. Our ongoing experiments produce F1 and accuracy scores that we use to assess the performance of both parts of our proposed pipeline. We also present the proportion of well-classified links, separated by their node of origin, either trolls or real activities. Interestingly, the Russian and Chinese experiments suggest that trolls are indeed more predictable. So to summarize our ongoing findings, we have taken structural cues to learn a model from user behaviors and then to perform node classification on them. We also found out that Russian and Chinese troll behavior looks more predictable than their surrounding real users. For future work, we consider important to leverage text information that comes in every tweet. As we conjecture, it will improve our results. Moreover, we conjecture that other sources of features, such as videos and images, would explain better phenomena, such as viral tweets by trolls. Thank you for your attention. Please feel free to reach out for further information and don't forget to check out our poster at the LatinX workshop. Hasta la próxima.
So I was wondering if you could elaborate on whether you found any regional features for detecting trolls in um, different spaces using this data. You mentioned something about China, like are posts. Yeah, I guess are there some features about this data that you have been able to derive that explains how different trolls behave in different regions, maybe?
Yeah, hi. Thank you for the question. Yeah, that's a very um, um, relevant thing, especially because the data we are using is, of course, divided by place of origin. So, yeah, so far, the only thing we identified is some correlations with the way like these accounts are motivated. So for example, like anything that comes from Russia, it's alleged to be like a little bit more elaborated. This is just according to the official reports, and they are also like targeted to, let's say, like more global events. Whereas like for example, the Chinese data, it's targeting its own country, its own like political region. So we actually did find that in terms of the link prediction task, there was some correlation with like the Russian datasets, like either the IRA or the like plain Russian datasets. But yeah, apart from that, there is of course a lot of work to be done, and there is also a lot of sub datasets that we haven't really explored. Which they have like different content, different complexity. Some of them they have like maybe more hashtags than others, and yeah, but yeah, I think that's like my answer to your question.
Thanks. Thanks. And are there any data sets specific to Latin America, do you know?
Yeah, there is I think Venezuelan data set, and there is one from Bolivia. So I haven't seen any other country. I think apart from that, probably I probably am missing a country in Central America. Not remember exactly. Like for me personally, I would like to see Mexican trolls, because I do think it's really something active in the Mexican like Twitter
Mhm.
verse. Yeah,
Maybe
the
it's time for
Venezuelan is the one that has more data.
maybe there's room for somebody to implement the data collection process. And I'm
Yeah,
hinting to you.
of course.
To continue with more questions, this is asking for all the authors in general. So how do you leverage the practical usage of the problems that you are solving with the chosen model?
Actually, if I understand the question correctly, in our case, we have to go a different route because our problem specifically, we target a more theoretical problem in terms of how to train a model which is sparse and how to do it in a flexible way. Um, so if we could follow up that question to something that would be a bit more applicable to perhaps our case, would be great.
Yeah, I feel that I don't know if this question is maybe intended to like works that are a little bit like more theoretical. Like I don't know, in my sense, I feel that I do a very applied um, uh, work with trying to identify and track trolls, internet trolls. Yeah, that's just my opinion.
Yeah, same thing from us from the pharmacovigilance paper. I mean, the model itself didn't really matter. I mean, it's just, the combination of how you get the data, how you frame the question, and, the model itself is just a tool to get something out of it. But we could have tried, anything from a very simple model to a very complicated model, but I think the end goal was a little bit something that would have come out anyways with any model we would have tried.